solid cylinder whose height is 2.4 centimeter and diameter is 1.4 centimeter. A conical cavity of the same height and same diameter is hollowed out. Okay, so first thing is first, conical cavity. So what is cavity? Well, we have the cavity word being used when we talk about our tooth, is it not? Say you guys eat something and don't take care of it basically. So it starts with this, and in time it becomes this. You know what I'm talking about? The cavity itself, right? It goes like that, and it goes like that, and yeah. Then we have to get it removed. If you don't maintain it, this is what will happen. Now we have a solid cylinder, like a solid tooth. We have a solid cylinder in which we have a conical cavity being dug out, hollowed out. What does it mean? So you have a cylinder like this, neat and clean, solid, solid everywhere, right? Fresh and neat. So if it happens to be, you know, hollowed out like this, that's what they mean. So this turning out of this is what is hollowed out. Can you see that? Right? That is the cylinder hollowed out. So I have a better view. This, right? Can you see that? That is your cone being hollowed out, right? Okay. Can you see the ghost view? So, matlab, translucent view. That's a better word. You see the translucent view, right? Okay. Now we have to calculate this. We have to make use of this bit zoomed version will help. Yeah, better. So we don't need that though. Let me clear that. Okay. So we are looking at this figure, right? And in exam also we need to do this. So basically, let me make use of it. So we have the cylinder, the original solid cylinder, to which we have a cone hollowed out, something like this, right? Okay, let's look at what is given. A solid cylinder whose height is 2.4. So the height is 2.4 centimeter. This is around 24 by 10 centimeter. Diameter is 1.4 centimeter. So this is 1.4 centimeter is 1.4 by 2 centimeter. Okay, 0.7 centimeter, which can be written as 7 by 10 centimeter. Okay, I always like to write the decimals in fraction form. Find out the total surface area of the remaining solid to the nearest centimeter square. Okay, so thing is we need the slant height, right? For slant height we need a Pythagoras, I mean not Pythagoras theorem, sorry, right angle triangle. So for that, this is our triangle. Okay, right? So this is 90-degree and we have to find this. So if you know Pythagorean triplets, 24 and 7, we know that this will be 25 by 10 centimeter. Okay, that's the advantage of knowing not too many things, little things in math. So moving on, what is given? So let's start calculating. Height of the cylinder is 24 by 10 centimeter. Next, radius of the cylinder is same as radius of the cone, and also this is height of the cone as well, right? By 2, right, 2 times. So diameter of the cylinder by 2, which is 1.4 by 2, right? It is 0.7, and I'll write 0.7 as Okay, let me write it over here. Why do we make it look congested? 7 by 10 centimeter. Now we can look into slant height of the cone. So it is nothing but radius of the cone square plus height of the cone square to the power of half. And this is equal to 7 by 10 into 7 by 10 plus height of the cone is 24 by 10 into 24 by 10 to the power of half. So what is, again, there's a square root. I don't want to take common and confuse you guys. Besides, it's just 10 tens in the denominator. So I don't want to do that. I mean, right, let me keep tens. That is 100. 100 is your LCM. So this is 49 plus 576, right, to the power of half. Right? And this is square root of 625 by square root of 100. And so the final answer is what? Slant height is equal to 25 by 10 centimeter. Okay, so a lot of writing for the initial things itself. But yes, it is almost done. Now we are looking at the next part. Total surface area done. Total surface area of the cone. Not cone, sorry, solid. So this is equal to, we'll begin with curved surface area. What? We can begin with, okay, let me remove this. Yeah, we can begin with the cylinder, right? So curved surface area of the cylinder, whose height is 24 by 10 and radius is 7 by 10. Plus, what else is left out? Plus, you have the cone, right? We have the cone. Okay, so let me show that again. We have the cone. The cone also gives us some surface area. So curved surface area of the cone. Again, all these are curved surface area. So slant height, because we use slant height, and radius is 7 by 10. And at last, we have what? It's one more thing. Can you guess what? Well, we are done with the curved surface area of the cylinder. This also, what else is left out? Can you guess? Any guesses? Well, it is the base. Right? See, base is not touched. A solid cylinder has its base intact. So we not touch this. So basically, what is the shape of the base? What is the shape? Okay. Yeah. No. What? Okay, let me do it with hand itself. I didn't observe that. Okay, yeah, you guys got it now. What is the shape? It's a circle. So area of a circle whose radius is 7 by 10. Same thing, right? All of it has the same radius. Now, because all of them have the same radius, we need not write any subscript. 2 pi RH. Subscript is nothing but all this 1, 2, 3, 4 there right now. I'll be writing in the future. So that is not there in this. So pi r square. So I'll write it as r into r. I'll show you why. So you have pi r common. So you have pi r into 2h plus L plus r, right? So all we have to do is substitute 32 by 7 into radius. All of the radius is same, 7 by 10. That's why I was able to take common. 2 into height, that is 24 by 10, plus slant height 25 by 10, plus radius 7 by 10. Okay, so we have 7 and 7 getting cancelled, and tens in the denominator. So 22 by 10 into 1 by 10. So this is 48 plus 25 plus 7. Right, simple addition. So this is 22 by 100 into 48 and 7 is 55, 60, 80. 80 by 100, so 0, 0 gets cancelled. So this is 16176 by 10 is 17.6 centimeters square. Right, and we have your answer. But there is one thing they're asking, make it to the nearest centimeter square. So basically they're asking us to approximate it to the nearest integer. So nearest integer is 18 centimeters square. Okay. Have a look at the answer.